residential buildings in India. So I started with the building use energy that is there with the literature review. So 40% of the total energy is used in building, and life cycle assessment is one of the parameters where we can assess the energy consumption of the building. And the methodology in this literature was followed in four steps. The first was life cycle inventory, then was life cycle assessment and interpretation of and data analysis. And I chose India because India is the 13th highest country in terms of carbon consumption. And it almost generates around 28,213 kilograms of CO2 per 1,000 individuals. And the aim of the study was to examine the residential construction in India in a metropolitan region. And with this thesis, I analyzed the embodied and the operational energy, and I compared the style of the construction that is there in India. And the methodology follows like by defining the scope and the parameters, because in the embodied and operational energy, defining the scope and the parameters plays a very important role. Then the inventory of the life cycle, evaluation and effects, and interpretation and results. So in this, I have studied transportation energy, construction energy, embodied energy, and the material energy. So as we have seen today in this scenario, embodied energy is one of the major aspects which we have to focus on, because for operational energy, we have a lot of passive techniques that can equalize it. But for the embodied energy, there are still researches that should be done. So first was the material energy of the building. So in this, I've taken a representative building, and I've studied the retrofit cycles of the building. So every building has a lifespan, and then each lifespan depends on the material we use. It depends on the service life also of the material. So with that, how many retrofits are done in the building? And so I have, with my research and literature review, I have tried to do the analysis as per the retrofit. So if the structure was using steel, so I have tried to analyze the structure if recycled steel is used after the service life of the steels. And in the same way for the concrete, the conventional concrete that is practiced, and replacing it with a fly ash concrete. So I have studied these parameters because the next was the transportation energy. So transportation energy, I've studied the parameters like from the A1 stage to A3 stages, where it included the raw material and the manufacturing and the transportation. So in that, I have studied these parameters, in which the type of the vehicle, the distance, and the availability of the products was also very much important. Then was the construction energy. So in the construction energy, the equipment, the type of equipment that is used for the construction plays a very major role. So on these parameters, I studied the type of equipment that are used and what was the energy consumption by these equipment. And for the results and discussions, when I did the analysis as per the retrofit of the structures for the existing building, so I saw that reducing the building weight, it contributes to the lesser amount of embodied energy, and reducing the material with a low embodied material, also replacing these, also reduces the carbon emission of the building. So what I found with my results, like there was a decrease of 42 to 56% by replacing the original, that is existing materials, with the alternative materials with my research. And so ultimately the concrete, the best alternative solution which was found as fly ash, and with the steel, it was found to be recycled steel. Thank you.
Thank you very much. That was on time. Thank you. Questions?
Question regarding, thank you very much for the presentation. Regarding is the office buildings, right? Residential, okay. And how did you choose? I guess you had to pick a building, right? And was it, and I guess the climate, if you're looking operational, were you looking at operational, right? As well as, yeah. So which climate, can you repeat if you said already and those? And in terms of the typology, because residential buildings can vary. So did you do a statistical analysis to see which one was the most commonly used? How did you go about choosing
Yeah.
the typology of residential? And in your opinion, what is the impact that maybe different typologies could make on your results?
So, starting Bombay, which I can see. So there was a structure, 3 to 4 structures were the most commonly and evident part. And these structures, I've also researched, like Bombay is a very, like a very old town. So we have these structures who need retrofitting. So that was also one of the parameters. So how many structures need retrofitting? So that was one of the major parameters that contributed, like where I should focus on. Like these structures should be focused on more embodied and how to balance the footprint over there.
Thank you. We have another question here.
Okay. Good afternoon, everyone, and thank you very much for your paper. It was a lot of information again. Mine is just a comment. I think it will enrich your work a lot. Around your methodology, I thought it might be helpful if you familiarize yourself with 2 international standards on LCA. That's ISO 14040 and ISO 14044. So in those documents, there is the international methodology, for all those processes that you try to explain. And I think that would have helped you to simplify your information. And then in the analysis itself, there are applications for the CIMA Pro is very common. If you do all that background work and you export it to CIMA Pro, then it will help a lot in, presenting your result. A lot of information, maybe you present it in a tidier way. That's just the observation I wanted to make to enrich your work. It's very interesting. Thank you.
Thank you very much. No, wait. One comment here. There's some water here. So please, if you walk, be careful. She was the one dropping the water. But be careful with that. So thank you very much for your presentation.